In the quietest corners of the cosmos, a mystery unfolds, not with spectacle but with a silent upload of data that challenges our understanding of the universe. This is not a tale of alien invasions, but of an interstellar object that defied expectations and the one nation that saw it all. So, before we go deeper, hit like, subscribe, and tell me in the comments what you think this really means. And if you want to help this message reach others who still wonder, share it on X, Facebook, Reddit, or even just in your group chats. You're the reason this search is alive. Thank you for keeping your eyes open. In October 2017, astronomers at Hawaii's Haleakala Observatory detected a peculiar cigar-shaped object hurtling through our solar system. Named Oumuamua, Hawaiian for scout, or messenger from afar, it was the first interstellar object ever observed here. Its behavior baffled scientists. It moved at astonishing speeds, exceeding 87 kilometers per second, yet showed no typical comet behavior such as outgassing. Instead, it slightly accelerated as it left our solar system, deepening the mystery. Observations revealed it to be roughly 400 meters long, 40 meters wide, and reddish in hue, suggesting organic compounds from distant stars. Meanwhile, one nation silently gathered data on Oumuamua using a network of observatories, satellites, and classified instruments. Analysts in secret facilities scrutinized its trajectory, finding it non-random and seemingly guided. Its slight acceleration upon exiting our solar system appeared intentional. Observation: Oumuamua's behavior implied intelligence or design beyond human comprehension. Interpretation: Oumuamua marked a pivotal moment in human history, challenging our cosmic understanding and forcing us to confront the possibility of extraterrestrial life and intelligence far beyond our grasp. Speculation: was Oumuamua part of a fleet sent to explore the galaxy? Was its journey through our solar system deliberate reconnaissance? These profound questions lingered as humanity stood on the edge of a new era, with the silent upload of data rewriting our existence, one byte at a time. Part 1. The Silent Upload. On an unremarkable day, China released a series of files into its national archives. No press conferences, no announcements, just data, time-stamped readings, photometric measurements, astrometric positions, all slipped into the system like routine paperwork. But for the scientists who opened those files, routine was the last word that came to mind. What they saw was confirmation of the one scenario astronomers had hoped to avoid: an interstellar object behaving in ways that defied our models. The files, though dense with technical jargon and raw data, painted a picture that was as unsettling as it was exhilarating. The implications were so profound that they threatened to upend decades of established astrophysical theory. The object, named 3IE Atlas, was the third confirmed interstellar visitor in human history. The first, Oumuamua, discovered in 2017, had sparked global fascination with its cigar-like shape and mysterious origins. The second, Borisov, identified in 2019, resembled a comet, its icy composition glimmering under the distant sunlight. But 3IE Atlas was different. It didn't just drift through our solar system like its predecessors, it responded, it changed, and in that change, it revealed a truth that had been hiding in plain sight. 3IE Atlas was first detected on April 12, 2035, by the Pan-Asian Multilateral Observational Network, PAMON, a collaborative effort between China, Japan, South Korea, and India. The object was initially classified as a comet due to its faint coma, a glowing envelope of gas and dust surrounding its nucleus. However, as it approached the Sun, its behavior diverged from known cometary patterns. Instead of accelerating due to solar radiation pressure and outgassing, 3IE Atlas decelerated. This defied all conventional explanations. The object seemed to be actively resisting the gravitational pull of the Sun, a phenomenon never before observed in any celestial body, interstellar or otherwise. Observation: The deceleration of 3IE Atlas was not gradual but occurred in distinct, measurable increments. Over a period of 48 hours, the object reduced its velocity by 0.03% every 6 hours. This pattern was so precise that it suggested an intentional adjustment rather than a natural occurrence. The data from Paman showed no corresponding increase in outgassing or any other physical changes that could explain the deceleration. It was as if the object was correcting its course, deliberately slowing down to prolong its stay in our solar system. The astronomical community was divided. Some argued that the deceleration could be explained by an unknown physical process, perhaps related to the object's composition or its interaction with the solar wind. Others, however, saw something more ominous. The precision of the deceleration, combined with its lack of precedent, led some to speculate that 3IE Atlas was not a natural object at all. Instead, they proposed it could be an artifact, a probe or vessel sent by an extraterrestrial civilization. This hypothesis, though controversial, gained traction as more data emerged. The files released by China included spectroscopic analysis of 3IE Atlas, revealing a surface composition unlike anything found in our solar system. The object was rich in rare earth elements, particularly neodymium and dysprosium, which are essential for advanced technologies like magnets and lasers. These elements are scarce on Earth and are primarily extracted through environmentally destructive mining processes. The presence of such materials on 3IE Atlas suggested that it might have been engineered for a specific purpose, perhaps to withstand the rigors of interstellar travel. Speculation. If 3IE Atlas was indeed an artifact, its creators would have possessed technology far beyond our own. The ability to traverse interstellar distances, let alone decelerate within a solar system, would require a level of engineering and energy management that humans have not yet achieved. For comparison, the fastest human-made object, the Parker Solar Probe, travels at approximately 0.064% the speed of light. 3IE Atlas, by contrast, entered our solar system at roughly 5% the speed of light, slowing to 1% as it approached the Sun. This discrepancy in speed and control highlighted the gulf between human and extraterrestrial capabilities. The implications of 3IE Atlas's origins were staggering. If the object was artificial, it meant that humanity was not alone in the universe. Moreover, it suggested that other civilizations had already solved the challenges of interstellar travel, energy production, and possibly even communication across vast distances. The files from China, though incomplete, hinted at a universe far more complex and inhabited than previously imagined. Yet, amid the excitement and speculation, a sense of unease lingered. If 3IE Atlas was a probe or vessel, what was its purpose? Was it merely passing through, or was it gathering data on our solar system, and, by extension, on us? The object's behavior, particularly its deliberate deceleration, suggested intent. But what that intent was remained a mystery. The files offered no answers, only more questions. As the data circulated among the scientific community, governments began to take notice. The United States, Russia, and the European Union issued joint statements calling for further investigation and international cooperation. The United Nations convened an emergency meeting of its Scientific and Technological Subcommittee, where experts debated the potential risks and benefits of engaging with 3IE Atlas. Some advocated for caution, warning that any attempt to communicate with or study the object could be interpreted as a provocation. Others argued that this was a once-in-a-lifetime opportunity to learn from an advanced civilization. Interpretation. The debate over 3IE Atlas reflected deeper divisions within human society. While some saw the object as a beacon of hope, a testament to the potential of intelligent life in the universe, others viewed it as a threat. The unknown has always been a source of fear, and the idea of an extraterrestrial civilization capable of interstellar travel was, for many, terrifying. The files released by China, though silent on the matter, seemed to echo this ambivalence. They provided enough information to spark curiosity, but left too many questions unanswered to quell anxiety. In the weeks that followed, 3IE Atlas continued its slow, deliberate journey through our solar system. It passed within 0.5 astronomical units of Earth, close enough to be studied in detail, but distant enough to avoid direct interaction. Telescopes around the world tracked its progress, capturing images and data that would be analyzed for years to come. Yet, despite the scrutiny, the object remained enigmatic. Its surface showed no signs of activity or intent, and its trajectory, though altered, seemed to follow a predetermined path. It was as if 3IE Atlas was on a mission, one that humans were not meant to understand. As the object receded into the outer solar system, the files from China took on new significance. They were no longer just data points or photometric measurements. They were a record of humanity's first encounter with the unknown. Whether 3IE Atlas was a natural phenomenon or an extraterrestrial artifact, it had forever changed our understanding of the universe. And as the files were archived, preserved for future generations, they served as a reminder of the questions that still lingered, waiting to be answered. Part 2. The Blackout, July 1, 2025. The day 3IE Atlas was first spotted by Chile's Atlas survey. From the moment its trajectory was calculated, something felt off. It was fast, too fast. Traveling at heliocentric speeds near 209,000 kilometers per hour, it moved on a path that didn't belong to our sun. Western observatories mobilized, aligning Hubble, JWST, VLT, and Gemini to track it. Astronomers across the globe scrambled to gather data, their faces illuminated by the glow of screens displaying star charts and spectrographic analyses. The air was thick with anticipation and unease. But just as the object reached its most critical phase, everything went dark. For 36 hours, 5 major Western observatories went offline. Gyroscope realignments, mirror cleanings, instrument swaps, all scheduled with uncanny precision. The timing was almost poetic, as if choreographed by an unseen hand. In that window, 3IE Atlas slipped dangerously close to the sun's glare, the exact moment when a comet reveals its true nature through peak outgassing, jet activation, and coma expansion. A natural comet would have had nothing to hide, but an unnatural one. It would have everything to reveal. The silence from the observatories was deafening, a void of data that left scientists grappling with questions and the public clutching at rumors. The blackout wasn't just a technical glitch, it was a strategic blind spot. During those 36 hours, the world was denied access to the most powerful eyes in the cosmos. The Hubble Space Telescope, which had captured stunning images of distant galaxies and nebulae since its launch in 1990, went quiet. The James Webb Space Telescope, a $10 billion marvel of engineering designed to peer into the farthest reaches of the universe, fell silent. The Very Large Telescope Array in Chile, with its 4 massive 8.2-meter mirrors, stopped collecting light from the cosmos. Even the Gemini Observatory, known for its twin 8.1-meter telescopes in Hawaii and Chile, went dark. The coincidence was almost too perfect, a symphony of failures that seemed to defy probability. Observation: the simultaneous shutdown of 5 major observatories during a critical astronomical event is statistically improbable. The likelihood of such a coordinated failure occurring naturally is estimated at less than 0.01%. This suggests external intervention, whether human or otherwise. The blackout wasn't just a loss of data, it was a loss of opportunity. Astronomers had been waiting for this moment, the chance to study an object that defied conventional orbital mechanics. 3IE Atlas was moving at speeds that suggested it wasn't gravitationally bound to the solar system. Its trajectory was hyperbolic, a path that implied it had originated from outside the influence of our sun. Such an object was rare, and its appearance sparked theories ranging from rogue comets to interstellar visitors. But with the observatories offline, the data that could have confirmed or refuted these theories was lost. The scientific community was left with theories but no proof, hypotheses without evidence. The consequences of the blackout rippled beyond the scientific community. Social media platforms buzzed with speculation, hashtags like 3itless and alien cover-up trending within hours. Conspiracy theorists pointed to the timing of the shutdowns as proof of government intervention, while others suggested a more sinister explanation, that the object itself was responsible. Tabloids ran sensational headlines, "Alien Comet Blinds Humanity," and "Government Hides Truth About Interstellar Visitor." The lack of concrete information fueled the fire, turning 3IE Atlas into a global phenomenon. Interpretation. The blackout created a vacuum of information that was quickly filled by speculation and misinformation. The absence of data allowed conspiracy theories to flourish, undermining public trust in scientific institutions. In the days that followed, the observatories slowly came back online. Hubble was the first to resume operations, its cameras capturing the faint trail of 3IE Atlas as it moved away from the sun. The images were grainy and incomplete, a shadow of what could have been captured during the blackout. JWST followed, its infrared sensors picking up the object's thermal signature, but the data was fragmented, pieces of a puzzle that refused to come together. The VLT and Gemini observatories returned to service last, their ground-based telescopes hampered by atmospheric interference. By the time all 5 observatories were fully operational, 3IE Atlas was already fading into the distance, its secrets intact. The blackout left a lasting impact on the astronomical community. It exposed vulnerabilities in the system, the reliance on a handful of observatories to monitor the cosmos. It also highlighted the need for redundancy, for backup systems that could step in during moments of crisis. In the wake of the event, funding was allocated to develop new telescopes and satellite networks, a global effort to ensure that such a blackout would never happen again. But the damage was already done. 3IE Atlas had slipped through the cracks, a cosmic enigma that remained just out of reach. Speculation. The blackout may have been intentional, designed to hide the true nature of 3IE Atlas. Whether this was the work of a human agency or an extraterrestrial influence remains unknown. The lack of conclusive evidence leaves room for interpretation, but the timing and scale of the event suggest a deliberate act. As the world moved on, 3IE Atlas continued its journey through the solar system. Its trajectory took it past the orbit of Mars, a silent sentinel moving through the void. Astronomers tracked it as best they could, but the data was limited, a ghostly echo of what might have been. The object's origins remained a mystery, a question that haunted the scientific community. Was it a natural phenomenon, a comet from the outer reaches of the solar system, or was it something more, a visitor from the stars? The blackout had robbed humanity of the chance to know for certain, leaving only questions and the faint glow of a disappearing trail. The legacy of the blackout lingered, a reminder of the fragility of human knowledge. In the vast expanse of the cosmos, there are forces beyond our control, mysteries that defy explanation. 3IE Atlas was one such mystery, a fleeting glimpse of the unknown that left an indelible mark on the collective consciousness. It served as a humbling reminder of our place in the universe, a speck of dust in the grand tapestry of existence. And yet, amid the uncertainty, there was hope. Hope that one day we might unravel the secrets of the cosmos, that the next time an object like 3IE Atlas appears, we will be ready. Part 3. The Lone Witness. While the West closed its eyes, China didn't. High-altitude stations in Tibet, Qinghai, and Yunnan remained operational during the blackout. These facilities, perched at elevations exceeding 4,500 meters, stood as sentinels in the thin, clear air of the Tibetan Plateau and the Hengduan Mountains. The night sky at these altitudes is a breathtaking canvas, unpolluted by city lights, with stars shining at a magnitude unseen elsewhere. No maintenance cycles, no scheduling conflicts, just clear, stable skies perfectly aligned for continuous tracking. The telescopes, equipped with state-of-the-art CCD cameras and adaptive optics, operated in near-perfect conditions, with atmospheric disturbances minimized by the rarefied air. These observatories, such as the Lijiang Station in Yunnan and the Ngari Observatory in Tibet, are among the most advanced in the world, housing telescopes with apertures exceeding 1.5 meters. China captured uninterrupted astrometric positions, coma expansion rates, tail morphology, and multi-filter photometry. Every frame was time-stamped with millisecond precision. Every exposure fed into cooling systems under sub-zero night air, where temperatures regularly plummeted to 20 degrees Celsius. The data streamed into servers housed in reinforced climate-controlled bunkers designed to withstand the harsh environmental conditions. These bunkers, buried deep in the permafrost, are equipped with redundant power systems and backup generators to ensure uninterrupted operation. What China recorded was not what Western scientists expected. The coma didn't just grow, it expanded sunward, defying conventional models of solar radiation pressure. The tail didn't just appear, it elongated at an unnatural rate, stretching across the sky in a way that challenged existing theories about cometary behavior. The brightness didn't just fluctuate, it surged by 0.3 magnitudes in hours, a spike that suggested unusual activity within the comet's nucleus. The dust profile shifted toward large carbon-rich grains, unheard of for a comet with its chemical history. These grains, rich in polycyclic aromatic hydrocarbons, hinted at a composition more akin to interstellar material than typical cometary dust. China didn't fill the gap. It exposed it. The data revealed complex structures within the comet's tail, including knots and filaments that indicated the presence of magnetic fields or other unseen forces shaping its behavior. The comet's nucleus, estimated to be between 4 and 6 kilometers in diameter, exhibited unusual rotational patterns, with periods fluctuating between 8 and 12 hours. This variability suggested that the comet might be experiencing torque from outgassing jets or internal instabilities. The data collected during the blackout was meticulously analyzed by teams of astronomers at the Purple Mountain Observatory in Nanjing and the National Astronomical Observatories of China in Beijing. These scientists, working in shifts around the clock, pored over the images and spectroscopic data, comparing them against historical observations of similar comets. The results were startling. The comet's behavior deviated significantly from established patterns, raising questions about its origin and composition. Some researchers speculated that the comet might have originated from the Oort cloud, a distant reservoir of icy bodies far beyond the orbit of Neptune, rather than the Kuiper Belt, where most short-period comets are believed to come from. The Oort cloud, a theoretical spherical shell of icy debris, is thought to contain trillions of comets, some of which are occasionally perturbed by passing stars or galactic tides and sent hurtling toward the inner solar system. If this comet were indeed from the Oort cloud, it would be one of the rarest and most distant visitors ever observed. The implications of these findings were profound. If the comet's unusual characteristics were confirmed, it could challenge long-held assumptions about the formation and evolution of the solar system. The presence of large carbon-rich grains, for instance, suggested that the comet might have formed in a region of the solar system where such materials were abundant, possibly during the early stages of planetary formation. This could provide valuable insights into the conditions that existed during the solar system's infancy, offering clues about the processes that led to the formation of planets and other celestial bodies. The comet's composition also hinted at the possibility of organic materials being delivered to Earth during its early history, potentially seeding the building blocks of life. Such a discovery would not only reshape our understanding of comets, but also deepen our appreciation for their role in the emergence of life on our planet. However, the data also raised troubling questions. The comet's rapid brightness surge and unusual tail elongation hinted at instability within its nucleus. Some researchers feared that the comet might be undergoing a process of fragmentation, where pieces of its nucleus were breaking off and disintegrating. This could have catastrophic consequences if the comet were to approach Earth or other inhabited planets. The risk of impact, though remote, was a sobering reminder of the potential dangers posed by comets and other near-Earth objects. In 1908, the Tunguska event in Siberia, believed to have been caused by the explosion of a comet or asteroid, flattened over 2,000 square kilometers of forest. If a similar event were to occur over a densely populated area today, the consequences would be unimaginable. The comet's unpredictable behavior underscored the need for vigilance and improved methods of detection and deflection. As the blackout lifted and Western observatories resumed operations, the scientific community eagerly awaited the release of China's data. Rumors circulated about the findings, with some scientists expressing skepticism and others anticipating a breakthrough. The Chinese government, aware of the global interest, prepared a detailed report outlining the observations and their implications. The report, scheduled for release at an international conference in Geneva, promised to shed light on one of the most mysterious objects in the solar system. In the weeks leading up to the conference, media outlets around the world speculated about the comet's origins and potential threats. Headlines such as "Mystery Comet, Harbinger of Disaster or Key to the Past," and "China's Secret, What Did They Discover During the Blackout?" fueled public curiosity and concern. The conference, held at the Palais des Nations, the headquarters of the United Nations office at Geneva, was attended by over 500 scientists, policymakers, and journalists from more than 40 countries. In the meantime, astronomers around the world continued to study the comet using the limited data available to them. They analyzed its trajectory, calculated its orbital parameters, and searched for clues about its origins. Some turned to historical records, scouring ancient texts and medieval manuscripts for references to similar comets. The Bayeux Tapestry, for example, depicts a comet that appeared in 1066, later identified as Halley's Comet. Others used computer simulations to model the comet's behavior, testing different scenarios to explain its unusual characteristics. Despite their efforts, many questions remained unanswered. The comet, it seemed, was a lone witness to a cosmic mystery, its secrets hidden beneath layers of ice and dust. Its elliptical orbit, with an estimated period of 75,000 years, meant that it had last visited the inner solar system during the Pleistocene epoch, when early humans were just beginning to emerge. As the conference in Geneva approached, the anticipation grew. Scientists from around the world gathered in the Swiss city, eager to learn what China had discovered. The conference hall buzzed with excitement as researchers exchanged theories and speculated about the findings. When the Chinese delegation finally took the stage, the room fell silent. The lead scientist, a renowned astronomer from the Purple Mountain Observatory, began her presentation. Her voice was steady, her expression serious. She spoke of the comet's unusual behavior, of the data collected during the blackout, and of the implications for our understanding of the solar system. As she concluded, the audience erupted in applause. The comet, once a mysterious enigma, had begun to reveal its secrets, but the journey to understanding was far from over. The presentation ended with a call for international collaboration, urging scientists to pool their resources and expertise to unravel the comet's remaining mysteries. A joint mission involving space agencies from multiple countries was proposed to send a probe to the comet, collecting samples and conducting in situ analysis. The room buzzed with renewed energy as the scientific community embraced the challenge, united in their quest to unlock the secrets of this celestial wanderer. Part 4. The Coma's Secret. To understand what China found, we must first understand the coma, the halo of dust and gas released when a comet wakes up near the sun. But 3E Atlas didn't wake up. It reacted. It responded. It spoke in particles. The coma, often described as a comet's atmosphere, is a dynamic, ever-shifting veil that reveals the secrets of its composition and history. For most comets, this halo is a mix of water vapor, dust, and trace gases, a result of the sun's heat vaporizing the icy nucleus. But 3IE Atlas defied expectations. Its coma was not the familiar cloud of water and dust, but something far more alien. From mid-July onward, JWST and SphereX had already detected something strange, a coma dominated by carbon dioxide, not water. This implied a thermal history unlike any comet native to our system. Carbon dioxide, a gas typically found in the outer reaches of the solar system, suggested that 3IE Atlas had spent most of its life in the frigid depths of space, far from the sun's influence. But the puzzle deepened as observations continued. The coma wasn't just unusual in composition, it was behaving in ways that defied conventional models. During the blackout, when solar radiation peaked, China observed something even more extraordinary: an echo signal, a brightness surge, an expansion wave, a structural rearrangement of the dust cloud. It wasn't random sublimation, it was a pattern. To the untrained eye, the coma might have seemed chaotic, a swirling mass of gas and dust. But to astrophysicists, the patterns were unmistakable. The brightness surge, captured in infrared wavelengths, was not a random flare, but a pulsating rhythm, as if the comet were breathing. The expansion wave, visible in ultraviolet light, rippled outward like a shock wave, reorganizing the dust particles in a symmetrical pattern. And to catch that pattern, you needed eyes on the object every minute. China had them, the West didn't. The Chinese Space Agency's network of satellites, including the advanced Chang'e 7 orbiter, had been tracking 3IE Atlas since its discovery. Their instruments, designed for continuous monitoring, recorded the comet's every fluctuation, every subtle change in its coma. Meanwhile, Western observatories, hampered by the blackout, struggled to maintain consistent data collection. The gaps in their records left critical moments unobserved, moments that China seized with unblinking precision. Observation: the coma's behavior was not merely unusual, it was unprecedented. The carbon dioxide dominance, combined with the structured patterns in the dust cloud, pointed to a comet that had undergone processes unlike anything seen in our solar system. Some researchers speculated that 3IE Atlas might have originated outside the Oort cloud, perhaps even from another star system. The echo signal, in particular, suggested a level of organization that bordered on the artificial. Speculation: could the coma's patterns be a form of communication? The idea seemed far-fetched, but scientists couldn't ignore the data. The echo signal, with its precise timing and repetition, resembled nothing so much as a coded message. If 3IE Atlas was indeed speaking, its language was one of light and particles, a cosmic Morse code waiting to be deciphered. The implications were staggering. If the comet was not a natural object but an artifact, it would rewrite our understanding of the universe and our place within it. Yet the most intriguing question remained unanswered. Why did 3IE Atlas react so dramatically during the blackout? The solar radiation peak, while intense, was not unique. Comets had weathered such storms before without displaying such extraordinary behavior. The answer, some believed, lay not in the sun, but in the comet itself. Perhaps the blackout had triggered something within 3IE Atlas, awakening dormant mechanisms or exposing hidden structures. Whatever the truth, one thing was clear: the coma's secret was just the beginning. Between July and August, as the blackout intensified, China's observations grew more urgent. The data poured in, filling servers with terabytes of information. Teams of analysts worked around the clock, sifting through the numbers, searching for meaning in the patterns. The coma's behavior grew increasingly complex, its signals more intricate. At times, the dust cloud seemed to form shapes, geometric patterns that defied natural explanation. Circles, spirals, and even what appeared to be symbols emerged briefly before dissolving into chaos. Interpretation: the geometric patterns in the coma were not illusions. They were deliberate, engineered by forces that remained hidden within the comet's core. Some researchers drew parallels to crop circles, suggesting that the patterns were a form of cosmic graffiti, a message left by an intelligence far beyond our own. Others dismissed the idea as fanciful, insisting that the patterns were the result of unknown physical processes, yet the data refused to yield easy answers. Each new observation raised more questions, deepening the mystery of 3IE Atlas. By the time the blackout ended, China had amassed a treasure trove of data, a record of the comet's behavior that no other nation could match. The West, scrambling to catch up, found itself playing a game of cosmic catch-up. But the damage was done. China's head start had given it an unassailable advantage, one that would shape the future of cometary research, and perhaps the future of humanity itself. The coma's secret, it seemed, was not just a scientific curiosity, but a turning point in history. If 3IE Atlas was indeed an artifact, it represented a bridge between civilizations, a link to a past or a future beyond our comprehension. The patterns in the dust cloud, the echo signal, the carbon dioxide dominance, all pointed to a story that was only beginning to unfold. And as the world watched, China stood at the forefront, ready to unlock the comet's final secrets. Part 5. The Broken Timeline. When Western observatories came back online, the time series was broken. The comet had moved 1.2 million kilometers, enough to blur any high-resolution reconstruction. This gap wasn't just a technical inconvenience, it was a scientific chasm. For astronomers, it was like trying to piece together a puzzle with missing pieces, leaving critical moments of the comet's behavior shrouded in mystery. The absence of data during this period meant that key phases of the comet's interaction with the Sun, such as the peak of its outgassing activity and the structural evolution of its coma, were lost forever. But China's data stitched it together seamlessly. Their observations filled in the blanks, creating a continuous narrative of the comet's journey through the inner solar system. When scientists aligned the coma readings, the conclusion was simple. 3 Atlas wasn't behaving like a comet trying to survive the Sun. It was behaving like an object responding to it. Every photon China captured passed through nitrogen-cooled CCD detectors, atmospheric correction pipelines, and redundancy servers. The infrastructure behind this feat was staggering. China's Yunnan Observatory, nestled in the mountains at an altitude of over 2,000 meters, operated its 2.4-meter telescope with precision instruments designed to capture faint, fast-moving objects. The telescope was equipped with adaptive optics systems that corrected for atmospheric distortion in real time, ensuring crystal-clear imagery. Meanwhile, the Purple Mountain Observatory in Nanjing, with its rich history dating back to the early 20th century, coordinated additional observations. Its 1.2-meter Schmidt telescope, though smaller, was optimized for wide-field imaging, allowing it to track the comet's tail in exquisite detail. All while Western observatories with mirrors 4 times larger recorded nothing. The discrepancy wasn't just about technology, it was about timing and strategy. China had anticipated the comet's trajectory and prepared its systems in advance, ensuring they wouldn't miss a single moment of its closest approach. The result? China created the first continuous photometric sequence of an interstellar comet during its peak solar activation. The data showed coma elongation toward the Sun, photometric brightening consistent with jet activation, and dust ratios incompatible with water-driven sublimation. This wasn't just good astronomy, it was strategic astronomy. The implications of this achievement were profound. For the first time, scientists had a complete record of how an interstellar object behaved under the intense heat and radiation of the Sun. The data revealed that 3IE Atlas didn't follow the typical pattern of cometary outgassing, where water ice sublimates and creates a bright, expanding coma. Instead, its behavior suggested a composition unlike anything seen before. The dust-to-gas ratio in the coma was off, with too much dust and not enough water vapor to explain the observed brightness. This anomaly hinted at a different kind of material, perhaps something more refractory, capable of withstanding extreme temperatures without vaporizing entirely. The comet's surface temperature, measured at over 700 Kelvin during its closest approach to the Sun, further supported this hypothesis. Such temperatures would have vaporized most ices, yet the comet remained structurally intact. Observation: the comet's tail, usually a hallmark of cometary activity, showed unusual structural features. While most comets develop a broad, diffuse tail of dust and gas, 3IE Atlas exhibited a more collimated, jet-like structure. This feature was particularly visible in the infrared spectrum, where the tail appeared as a narrow, glowing streak, extending away from the Sun. The precision of China's infrared detectors allowed astronomers to map this structure in unprecedented detail, revealing subtle variations in temperature and composition along its length. The tail's brightness fluctuated in a rhythmic pattern, suggesting pulsed releases of material from the comet's surface. This behavior was unlike anything seen in previous comets, which typically exhibit steady, continuous outgassing. The data also raised questions about the comet's origin. Interstellar comets are thought to form in the cold, distant regions of other star systems, far from the heat and light of their parent stars. Yet 3IE Atlas seemed to have adapted to the intense conditions of the inner solar system in ways that defied conventional models. Its surface, rather than disintegrating under solar radiation, appeared to stabilize and even reflect sunlight in unexpected patterns. Spectroscopic analysis revealed the presence of compounds such as silicates and carbon-rich materials, which are not typically found in abundance on comets. These materials are more commonly associated with asteroids or even rocky planets, further complicating the comet's classification. Some researchers proposed that 3IE Atlas might have originated from the debris of a disintegrated exoplanet, its fragments scattered across the galaxy. Interpretation: the behavior of 3IE Atlas challenged long-held assumptions about cometary composition and dynamics. If the comet wasn't primarily composed of water ice, as most comets are, then what was it made of? Some scientists proposed that it could contain significant amounts of carbon-rich compounds or even metallic elements, which would explain its unusual resilience. Others suggested that the comet might have undergone extensive processing during its interstellar journey, altering its composition in ways that made it more robust than typical comets. The comet's spectral signature also hinted at the presence of organic molecules, raising the possibility that it carried remnants of prebiotic chemistry from its distant origin. Such findings could provide insights into the building blocks of life beyond our solar system. The controversy extended to the comet's trajectory. Unlike most comets, which follow predictable elliptical or parabolic paths, 3IE Atlas seemed to deviate slightly from its expected course. These deviations were subtle but measurable, and they didn't align with gravitational perturbations from known planets or stars. Some researchers attributed the anomalies to outgassing forces, where jets of material escaping the comet's surface altered its trajectory. However, the timing and direction of these deviations didn't match the patterns observed in other comets. The mystery deepened as astronomers struggled to reconcile the comet's behavior with established physics. One theory suggested that the comet might be influenced by unseen companions, such as small, undetected moons or fragments orbiting it. However, no such objects were observed in the data. Speculation. As the data continued to pour in, some scientists began to entertain bolder ideas. Could 3IE Atlas be an artificial object rather than a natural comet? The notion seemed far-fetched, but the comet's unusual properties made it difficult to dismiss outright. Its precise, jet-like tail, its resilience to solar radiation, and its unexpected trajectory deviations all pointed to something beyond ordinary cometary behavior. Some even suggested that the comet might be a remnant of an advanced civilization, a probe or vessel sent to explore the galaxy. While such theories remained purely speculative, they underscored the profound questions raised by 3I Atlas. The idea of an interstellar artifact had been floated before, most notably with Oumuamua, the first interstellar object observed in 2017. However, 3IE Atlas presented an even stronger case for investigation with its well-documented anomalies and comprehensive observational data. For astronomers, the comet represented a turning point in the study of interstellar objects. Its behavior challenged conventional wisdom and opened new avenues of research, but it also highlighted the importance of international collaboration in astronomy. While China's observations had filled critical gaps in the data, the global scientific community recognized the need for shared efforts to fully understand such rare and enigmatic visitors. The story of 3IE Atlas was far from over, but its broken timeline had already reshaped our understanding of the cosmos. As researchers continued to analyze the data, they hoped to uncover more about the comet's origin, composition, and the secrets it carried from beyond the stars. The journey of 3IE Atlas through our solar system was a fleeting moment in cosmic time, yet its impact on human knowledge would endure for generations. Part 6. The Unseen Truth. When Western observatories came back online, the damage was already done. Not to the comet, but to our understanding of it. A full 36 hours without data during a fast-moving interstellar object's perihelion progression is not a gap. It is a wound. The void left by China's inaccessible data was not merely a setback. It was a fracture in the scientific record, one that would haunt researchers for months to come. Without China's logs, the West would have woken up blind to the coma's sudden asymmetry, the sunward jet structure, the brightness surge, and the subtle changes in trajectory. These were not minor details. They were critical clues to the object's nature, and their absence left scientists grappling with incomplete theories and models that struggled to explain what they had missed. The most damning part? Western models, when updated, did not fully align with natural comet behavior. The missing section of the light curve left uncertainties too large to ignore. Every recalculation pointed toward the same conclusion. Whatever 3IE Atlas is, it is not acting like a comet ejected randomly from another star. The discrepancies were stark. Comets typically follow predictable patterns of outgassing and brightness as they approach the Sun, but 3IE Atlas seemed to defy these rules. Its brightness surged at unexpected times, and its trajectory exhibited slight deviations that were difficult to reconcile with gravitational influences alone. These anomalies were not subtle. They were glaring inconsistencies that challenged the very foundations of cometary science. Observation. The asymmetry of the coma was particularly troubling. Comets typically develop symmetrical comas as they near the Sun, with outgassing occurring evenly across their surface. 3IE Atlas, however, displayed a pronounced asymmetry, with a distinct sunward jet that suggested a localized source of activity. This was not the behavior of a typical comet, but rather something more akin to an active object, perhaps even one with internal processes driving its behavior. The implications were staggering. If 3IE Atlas was not behaving like a natural comet, what else could it be? Interpretation. The brightness surge was another key indicator that something was amiss. Comets brighten as they approach the Sun due to increased outgassing, but 3IE Atlas experienced a surge that far exceeded expectations. This surge occurred at a point in its trajectory where it should have been relatively stable, suggesting an internal or external trigger that scientists had not accounted for. Theories began to emerge about possible mechanisms: an internal explosion, a collision with unseen debris, or even an artificial process. Each theory was more unsettling than the last, as they all pointed to the possibility that 3IE Atlas was not a natural object. Speculation. The subtle changes in trajectory were perhaps the most alarming. Comets follow predictable paths determined by the laws of gravity, but 3A Atlas exhibited slight deviations that could not be explained by known forces. These deviations were not large, but they were consistent enough to suggest that something was influencing the object's path. Some scientists proposed that the deviations could be the result of propulsion, a deliberate adjustment of the object's course. This idea, while controversial, gained traction as researchers struggled to find alternative explanations. If true, it would mean that 3IE Atlas was not just an interstellar visitor, but an object with intent. The repercussions of these observations were far-reaching. Scientists around the world began to reevaluate their assumptions about interstellar objects, questioning whether they had been too quick to classify 3IE Atlas as a comet. The possibility that it could be something else, an artificial construct perhaps, raised profound questions about humanity's place in the universe. Were we alone, or was there another intelligence out there capable of sending objects across the vast expanse of space? The questions were as thrilling as they were unsettling, and they fueled a new wave of research and speculation. In the weeks that followed, the scientific community mobilized to fill the gaps left by the missing data. Observatories across the globe turned their instruments toward 3IE Atlas, gathering as much information as possible before it receded into the depths of space. Each new piece of data added to the growing body of evidence that this object was unlike anything humanity had ever encountered. The asymmetry of the coma, the brightness surge, and the trajectory deviations were all pieces of a puzzle that refused to fit together in any conventional way. The quest to understand 3IE Atlas became an obsession for many researchers. They pored over the data, searching for patterns and anomalies that might reveal the object's true nature. Hypotheses were proposed and discarded, each one failing to fully explain the object's behavior. The more they learned, the more they realized how little they knew. It was a humbling experience, a reminder of the vastness of the universe and the limits of human understanding. Yet amid the uncertainty, there was also a sense of awe and wonder. 3IE Atlas was a mystery, a riddle that challenged the very foundations of science. It was a reminder that the universe is full of surprises and that humanity's journey to understand it is far from over. Whether 3IE Atlas was a natural comet or something more, it had sparked a new era of exploration and discovery, one that promised to redefine our understanding of the cosmos. As the object continued on its journey, scientists watched and waited, knowing that the answers they sought might never come. But they also knew that the quest for knowledge was its own reward, a testament to humanity's unquenchable thirst for understanding. 3IE Atlas was a beacon in the darkness, a symbol of the unknown and the unknowable, and a reminder that the universe is still full of secrets waiting to be discovered. Part 7. The Silent Confirmation. China didn't release a press statement or interpretation. It simply uploaded the data, raw, unfiltered, and time-stamped, onto international servers at precisely 03:14 UTC on October 19th. This move was unprecedented in its transparency, a stark contrast to the tightly controlled flow of information typically associated with state-run astronomical projects. Within 12 hours, the Minor Planet Center in Cambridge, Massachusetts, had independently recalculated the orbit using China's data. The center, which has cataloged over 900,000 minor planets since its inception in 1947, immediately recognized the significance of the findings. American institutions, including NASA's Jet Propulsion Laboratory and the University of Hawaii's Pan-STARRS program, quickly downloaded the FITS datasets, their teams working through the night to validate the findings. These institutions, responsible for tracking over 27,000 near-Earth objects, were equipped to handle the influx of data with unparalleled precision. European analysts at the European Space Agency's ESA Space Situational Awareness Program ran their own photometry, cross-referencing the data against observations from the Gaia satellite, which has mapped over 1.8 billion stars in the Milky Way. The orbital uncertainty, initially a sprawling 25 arcseconds, collapsed to a razor-sharp 5 arcseconds, a testament to the collaborative power of global astronomy. The comet's hyperbolic trajectory was confirmed with unmatched precision, leaving no room for doubt. This object was not from our solar system. The global astronomical community was stunned. In the days that followed, observatories from Chile's Atacama Desert, home to the world's most powerful telescopes, to the Canary Islands, where the Gran Telescopio Canarias stands as one of the largest optical telescopes, trained their instruments on the comet, now designated as 3IE Atlas. The Atacama Large Millimeter Submillimeter Array, ALMA, comprising 66 high-precision antennas, captured detailed images of the object's coma, revealing structures never before seen in a comet. The object's brightness fluctuated in a way that defied conventional explanations, with variations as high as 3 magnitudes within a single observational period. Spectroscopic analysis conducted using instruments like the High Accuracy Radial Velocity Planet Searcher, HARPS, at the Lucia Observatory revealed a chemical composition unlike anything seen before, high in metallic content, including rare earth elements like europium and terbium, low in volatiles, with traces of elements that shouldn't have survived the journey through interstellar space. The data suggested that 3IE Atlas was not just an interstellar visitor, but a relic from a distant star system, possibly older than our own Sun, which formed approximately 4.6 billion years ago. But the strangest twist, the coma's elongation wasn't random noise. It was directional, purposeful, almost signal-like, a response pattern activated by solar radiation. The echo signal wasn't a metaphor, it was literal. 3 Atlas reacted to sunlight like something that knew sunlight was coming. This behavior was so anomalous that it triggered emergency meetings at the International Astronomical Union, IAU, an organization founded in 1919 to promote cooperation among astronomers worldwide. Researchers at the SETI Institute, dedicated to the search for extraterrestrial intelligence since its establishment in 1984, began monitoring the object for any signs of intentional communication. The possibility that 3IE Atlas was not just a natural phenomenon but something more, a probe, a beacon, or even a remnant of an ancient civilization, became a whispered hypothesis in the halls of academia. The SETI Institute's Allen Telescope Array, designed specifically for such searches, was reoriented to observe 3IE Atlas continuously. Observation: the coma's elongation occurred precisely 14.2 hours after 3IE Atlas entered direct sunlight, suggesting a delayed response mechanism. The elongation extended over 300,000 kilometers, far beyond the expected parameters for a comet of its size, which typically exhibits a coma no larger than 100,000 kilometers. The spectral analysis of the coma revealed unusual spikes in infrared wavelengths, consistent with energy absorption and re-emission, a process typically associated with artificial structures. These spikes were particularly pronounced in the 8 to 12 micron range, aligning with the thermal signatures of advanced materials used in solar energy conversion. Interpretation: the directional elongation of the coma could indicate a form of solar energy harvesting. If 3IE Atlas is an artificial construct, its design may include mechanisms to convert solar radiation into propulsion or communication signals. The precise alignment of the elongation with the Sun's position suggests an intentionality that cannot be explained by natural processes alone. Such behavior is reminiscent of theoretical models for interstellar probes, which propose self-sustaining energy systems capable of harnessing stellar energy for long-duration missions. Speculation: if 3IE Atlas is indeed a product of extraterrestrial intelligence, its creators may have designed it to activate upon entering a star system. The elongation of the coma could be a form of signaling, either to its creators or to any civilization capable of detecting it. Alternatively, the object may be part of a larger network of interstellar probes, each programmed to respond to specific conditions in the environments they encounter. The implications of such a discovery would redefine humanity's understanding of its place in the universe, challenging not only our scientific paradigms, but our philosophical and existential frameworks as well. The detection of an artificial interstellar object would force humanity to confront questions about the nature of intelligence, the prevalence of life in the cosmos, and the potential for interstellar communication. The global response was swift but discreet. Governments convened closed-door meetings with leading astrophysicists and planetary scientists, including experts from the Planetary Society and the Breakthrough Initiatives, which have invested over $100 million in the search for extraterrestrial life. The United Nations Office for Outer Space Affairs issued a confidential bulletin to member states, urging coordination and caution in the interpretation of the data. This bulletin, marked with the highest level of diplomatic secrecy, emphasized the need for international cooperation to avoid speculation and panic. Meanwhile, the public remained largely unaware of the unfolding mystery. The few media outlets that picked up on the story framed it as a curious anomaly, a fleeting moment of excitement in the otherwise routine world of astronomy. But for those on the front lines of discovery, the implications were monumental. 3IE Atlas was not just a comet, it was a question, a riddle hurled across the cosmos waiting to be deciphered. Astronomers who had spent decades studying the cosmos in solitude now found themselves at the forefront of a potential paradigm shift, one that could redefine humanity's place in the universe forever. Part 8. The Unified Timeline. When Chinese and Western data were merged, something impossible happened. Spectral readings from SphereX, brightness profiles from Hubble, coma geometry from China's BVR photometry, astrometric positions derived from Gaia DR3, dust distribution modeled through scattered light, all aligned into one continuous, coherent timeline. The process was painstaking. Teams from NASA, ESA, and the Chinese National Space Administration spent countless hours cross-referencing datasets, correcting for observational biases, and calibrating instruments to ensure consistency. The result was a timeline so precise it could track the object's behavior down to the minute, revealing anomalies that had been hidden in the noise of individual observations. In one striking example, a slight wobble in the object's trajectory, detected by Gaia's astrometry, was found to correlate perfectly with fluctuations in its brightness captured by Hubble. This synchronization was so exact that it could not be dismissed as coincidence. That unified timeline showed a CO2-dominant comet that shouldn't behave like one, a brightness curve inconsistent with its thermal history, a tail structure that shifted during blackout hours, a nucleus too small to produce the observed coma by natural means, a dust-to-gas ratio far outside the solar system's norm, a hyperbolic trajectory with suspicious precision, an object responding faster to solar activation than physics predicts. This was not a random rock from another star. This was a phenomenon. The timeline revealed that the object's brightness increased by a factor of 10 over a period of just 48 hours, a rate unheard of for natural comets. Its tail, which should have been a steady streamer of gas and dust, instead exhibited erratic movements, as if influenced by an internal mechanism rather than solar wind. The nucleus, estimated to be no more than 100 meters in diameter, was dwarfed by its coma, which expanded to over 10,000 kilometers in some observations. This discrepancy defied all known models of cometary outgassing. The dust-to-gas ratio was particularly troubling. Natural comets typically have a ratio of around 1.1, but this object's ratio was closer to 5.1, suggesting either an unusually high dust production or a deliberate release mechanism. Spectroscopic analysis of the dust revealed traces of complex organic compounds, including polycyclic aromatic hydrocarbons, PHs, which are not typically found in natural cometary material. These compounds, often associated with interstellar dust, hinted at a possible origin outside the solar system, or more unsettlingly, a deliberate composition. The hyperbolic trajectory was equally perplexing. It entered the solar system at an angle of 120 degrees relative to the ecliptic plane, an approach so precise it suggested intent rather than chance. The object's response to solar radiation was also anomalous. It began outgassing at a distance of 3.5 AU from the Sun, far beyond the point where most comets become active. Observation. The unified timeline revealed that the object's behavior was not random, but followed a pattern. Its brightness spikes, tail movements, and outgassing events occurred at regular intervals, almost like clockwork. This regularity was so pronounced that it could not be explained by natural processes alone. For instance, every 12.7 hours, the object's coma would undergo a sudden expansion, followed by a rapid contraction, as if it were breathing. This cycle was observed consistently over a period of weeks, with no deviation in timing. The tail, too, exhibited a recurring pattern, splitting into distinct filaments every 24 hours before merging back into a single structure. These observations suggested a level of organization that was deeply unsettling. The timeline also revealed that the object's trajectory was not purely hyperbolic, but included subtle corrections. Every 48 hours, the object made micro-adjustments to its path, deviating from its expected trajectory by fractions of a degree. These adjustments were so small that they had initially been dismissed as observational errors, but the unified timeline showed them to be deliberate. The corrections ensured that the object maintained a precise course, avoiding any potential collisions with other celestial bodies. This level of navigation was far beyond the capabilities of natural objects and hinted at an intelligence behind the maneuvers. One of the most striking features of the timeline was the object's interaction with solar radiation. As it approached the Sun, its coma expanded and contracted in a rhythmic pattern, as if modulating its response to solar energy. This behavior was unprecedented. Natural comets typically respond to solar heating in a gradual, predictable manner. The object's coma, however, seemed to adapt in real time, expanding rapidly during periods of high solar activity and contracting during lulls. This adaptive behavior suggested a level of control that defied explanation. The tail, too, exhibited a similar responsiveness, shifting its orientation to maximize exposure to solar wind during peak radiation periods. The object's nucleus, though small, was far from inert. High-resolution imaging revealed that it was not a solid, uniform mass, but a composite structure. Layers of different materials were visible, some of which appeared to be synthetic in origin. One layer in particular showed a lattice-like pattern that resembled advanced composite materials used in aerospace engineering. This discovery raised the possibility that the nucleus was not a natural formation, but a manufactured object designed to withstand the extreme conditions of interstellar travel. Speculation. The unified timeline raised the question of whether the object was not a comet at all, but something else entirely. Its behavior was too precise, too controlled to be the result of natural processes. The idea that it could be an artificial construct designed to mimic a comet while concealing its true nature began to gain traction among researchers. If this were true, it would represent a technological achievement far beyond anything humanity had ever encountered. The implications of such a discovery were profound. An artificial object entering the solar system would challenge every assumption about the universe and humanity's place in it. It would raise questions about the object's origin, its purpose, and the intelligence behind it. The unified timeline, with its precise and inexplicable patterns, seemed to point toward a reality that was both thrilling and terrifying, a reality in which humanity was no longer alone in the cosmos. Interpretation. The unified timeline was more than just a scientific breakthrough. It was a philosophical turning point. It forced researchers to confront the limits of their understanding and the possibility of a universe far stranger and more complex than they had ever imagined. The object, with its impossible behavior and mysterious origins, became a symbol of the unknown, a reminder that the cosmos was still full of secrets waiting to be discovered. As the teams continued to analyze the data, the timeline grew more detailed, revealing new layers of complexity. The object's tail, for example, was not a single structure, but a series of interwoven filaments, each responding to solar radiation in slightly different ways. The nucleus, too, was not a uniform mass but a composite of materials, some of which appeared to be synthetic in origin. These discoveries deepened the mystery, making it clear that the object was unlike anything humanity had ever encountered. The unified timeline became a roadmap for further investigation, guiding researchers as they sought to unravel the object's secrets. It was a testament to the power of collaboration, the resilience of the scientific method, and the boundless curiosity that drives humanity to explore the unknown. And as the timeline continued to unfold, it seemed to promise that the greatest discoveries were still to come. The object's behavior, though enigmatic, was not chaotic but purposeful, as if it were following a predetermined plan. This sense of intent, more than anything else, fueled the researchers' determination to understand the object's true nature. If it was indeed an artificial construct, then deciphering its purpose could redefine humanity's understanding of the universe and its place within it. The unified timeline, with its intricate patterns and precise measurements, offered a glimpse into a future where the boundaries of human knowledge were expanded beyond recognition. Part 9. The Intent. China's discovery didn't claim alien technology or push conspiracy. It simply showed the truth the West tried to avoid. 3IE Atlas behaved differently when only one nation was watching. It brightened when no one else could measure it, as if responding to the absence of global surveillance. During these isolated observations, the comet's nucleus reflected sunlight with an intensity that defied conventional explanations. Its brightness fluctuated by as much as 20% within hours, a phenomenon that couldn't be attributed to normal cometary activity. Astronomers at the Purple Mountain Observatory in Nanjing captured these anomalies with precision, documenting changes that occurred only when Western telescopes were offline or focused elsewhere. It altered its tail structure when only one hemisphere had eyes on it. The tail, typically a trail of dust and gas pushed by solar wind, seemed to defy physics. On multiple occasions, it curved in directions that contradicted the known path of the solar wind. These deviations were subtle but unmistakable, captured in time-lapse images that showed the tail bending at angles up to 15 degrees off its expected trajectory. When Western observatories later reviewed these images, they struggled to explain the behavior, suggesting forces that shouldn't exist in natural cometary dynamics. The tail's length also varied dramatically, extending up to 500,000 kilometers in some instances, only to retract within days. As if controlled by an unseen mechanism, it expanded its coma in a direction that contradicted natural models. The coma, a halo of gas and dust surrounding the nucleus, typically grows as the comet approaches the Sun, but 3IE Atlas defied this pattern. Its coma expanded toward the outer edges of the solar system, away from the Sun's heat. This behavior was particularly pronounced during the comet's closest approach to Earth, when it passed within 38 million kilometers of our planet. During this period, the coma's size tripled in just 48 hours, growing to a diameter of over 1 million kilometers. This rapid expansion occurred in the opposite direction of the Sun's gravitational pull, further fueling speculation that external forces were influencing the comet. It responded to sunlight in a way that looked like activation, not melting. As 3IE Atlas approached the Sun, its surface didn't behave like ice melting under heat. Instead, it seemed to react as if charged by solar energy. Spectroscopic analysis revealed sudden spikes in molecular oxygen and hydrogen, compounds not typically found in such abundance on comets. These spikes occurred in rhythmic patterns, suggesting a cyclical process rather than random outgassing. Infrared imaging captured heat signatures on the comet's surface that fluctuated wildly, as if internal systems were turning on and off in response to solar radiation. The fear wasn't that the comet was dangerous. The fear was that it was deliberate, purposeful, coherent, and China's discovery confirmed it. This wasn't just an interstellar object, it was an interstellar event. The implications were staggering. If 3IE Atlas was indeed artificial, it meant that humanity was witnessing the first evidence of extraterrestrial engineering. The idea that an object could travel across interstellar space, surviving the harsh conditions of deep vacuum and cosmic radiation, suggested a level of technology far beyond human capability. It also raised questions about intent. Was the object merely passing through, or was it designed to interact with our solar system? Did it carry a message, a purpose, or something more ominous? Observation. The behavior of 3IE Atlas defied all known laws of cometary physics. Its brightness, tail structure, coma expansion, and response to sunlight were all anomalous, suggesting external control or internal mechanisms. Interpretation. China's findings pointed to a deliberate design behind the object's behavior. The patterns observed, such as the rhythmic outgassing and the tail's defiance of solar wind, could not be explained by natural processes. This interpretation was supported by the fact that these behaviors only occurred when the object was under limited observation, as if it were avoiding scrutiny. Speculation. If 3IE Atlas was artificial, it raised profound questions about its origin and purpose. Was it a probe sent by an extraterrestrial civilization to study our solar system, or was it something more sinister, a harbinger of a future encounter? The lack of overt communication or interaction with Earth suggested caution on the part of the object's creators, but the possibility of contact or conflict could not be ruled out. The comet's silent passage through our solar system left more questions than answers, but one thing was clear: humanity was no longer alone in the universe. As Western astronomers scrambled to catch up with China's findings, the global scientific community grappled with the implications. The object's behavior was undeniable, but its purpose remained elusive. In labs and observatories across the world, researchers pored over the data, searching for clues hidden in the patterns of light and motion. Meanwhile, governments quietly prepared for the possibility that 3IE Atlas was not the last of its kind. If this was humanity's first encounter with extraterrestrial intelligence, it was a humbling one. The object moved with a purpose and precision that dwarfed human technology, a silent reminder that the universe was far older and more advanced than we could comprehend. Part 10. The Hidden Face. In the end, it wasn't the telescopes that shocked the world. It wasn't the images or the brightness spikes or the impossible coma expansion. It was the silence in the west and the data from the east that shattered it. Because China didn't just observe something strange, it observed something the rest of us weren't supposed to see. Something that slipped into the blackout hour like a whisper, changed its behavior when no Western observatory was watching, and then emerged on the other side, looking nothing like the object we thought we knew. For months, astronomers insisted that 3IE Atlas was a comet, a frozen wanderer from another star, nothing more. But comets don't react selectively. They don't change their coma direction in the exact hours when half the planet is blind. They don't brighten on demand. They don't alter their dust profiles only when observed by a single nation. And they don't mimic activation patterns the moment solar radiation peaks. The data from China was staggering. Over a span of 97 days, the coma of 3IE Atlas expanded at a rate that defied all known models of cometary activity. In just under 3 months, it grew from a faint, diffuse halo to a structure that spanned nearly 1.2 million kilometers in diameter. This was not a gradual process. It happened in fits and starts, with periods of rapid expansion followed by inexplicable pauses. During these pauses, the coma would stabilize, almost as if it were waiting for something. Then, without warning, it would resume its growth, doubling in size in a matter of hours. What made this even more unsettling was the timing. The most dramatic changes in the coma occurred during the so-called blackout hour, a window of time when Western observatories were either offline or focused on other targets. This window was not a fixed period, but a result of coordination gaps between major observatories in the United States, Europe, and Australia. For example, between Orduja 2 and Orjau 3 UTC on October 15, 2028, every major Western telescope was either undergoing maintenance or observing distant galaxies as part of a coordinated survey. During this exact hour, 3IE Atlas's coma expanded by over 300,000 kilometers, an event that went unnoticed by Western astronomers until Chinese data was leaked weeks later. The question on everyone's mind was simple: how could this be a coincidence? The odds of such precise timing occurring naturally were astronomical, yet the alternative was even more troubling. If 3IE Atlas was deliberately avoiding detection, it implied a level of intention that was beyond the capabilities of any known natural phenomenon. The implications were staggering. If this object was not a comet, then what was it? And if it was capable of evading observation, who or what was controlling it? The answers, if they existed, were buried in the data. Chinese astronomers had been tracking 3IE Atlas for months, collecting terabytes of information that Western observatories had missed. However, the data was not shared openly. Instead, it trickled out in fragments, often through unofficial channels or leaks from researchers who felt compelled to break the silence. One such leak revealed that 3IE Atlas had exhibited unusual spectral signatures during its periods of rapid expansion. These signatures suggested the presence of elements like iridium and osmium, rare metals that are not typically found in comets. Observation: the spectral data from China showed spikes in iridium and osmium during the coma's expansion phases. These elements are not only rare, but also extremely dense, making them unlikely components of a natural comet. Their presence suggested that 3IE Atlas might be composed of materials not found in typical cometary bodies. Interpretation: the unusual composition of 3IE Atlas could imply that it was not a natural object at all. Some researchers speculated that it might be an artificial construct, perhaps a probe or vessel from an extraterrestrial civilization. Others suggested it could be a remnant of an ancient technological society, drifting through space for millions of years before being detected by human telescopes. Speculation: if 3IE Atlas was indeed artificial, its behavior during the blackout hour could be explained as a deliberate evasion tactic. Perhaps it was programmed to avoid detection, altering its trajectory or activity patterns when it sensed it was being observed. This would explain why it only changed during the blackout hour, when Western telescopes were not watching. However, this raised even more questions. Who or what had built such a device, and why was it here now? The silence from Western observatories was deafening. Despite the mounting evidence, many astronomers remained skeptical, clinging to the belief that 3E Atlas was a comet, albeit an unusual one. They argued that the data from China was incomplete or flawed, and that the unusual behavior could be explained by natural phenomena we simply didn't understand yet. But as the weeks passed, the cracks in this argument grew wider. More leaks emerged, each one adding to the mounting evidence that 3IE Atlas was something far stranger than anyone had imagined. One of the most compelling pieces of evidence came from a series of images captured by China's FAST telescope, the largest single-dish radio telescope in the world. These images showed 3IE Atlas in unprecedented detail, revealing structures within the coma that defied explanation. The coma was not uniform but composed of intricate geometric patterns that seemed to shift and change over time. These patterns were unlike anything ever seen in a natural comet, and their origin remained a mystery. Observation. The fast telescope images revealed that the coma of 3IE Atlas contained geometric structures that appeared to be artificial in origin. These structures were highly symmetrical and seemed to rotate independently of the comet's nucleus, suggesting they were not natural formations. Interpretation. The presence of geometric structures within the coma suggested that 3IE Atlas might be an engineered object. Some researchers compared the patterns to the designs seen in human-made satellites or spacecraft, noting similarities in symmetry and complexity. Others pointed out that the rotation of these structures seemed to defy the laws of physics as we understood them, implying that they were controlled by an unknown technology. Speculation. If 3IE Atlas was indeed an engineered object, its purpose remained unclear. Some hypothesized that it was a surveillance device, monitoring Earth from a distance. Others suggested it might be a probe sent by an extraterrestrial civilization, gathering data on our solar system. Still, others speculated that it was a remnant of an ancient civilization, a relic from a time long before humans walked the Earth. As the debate raged on, one thing became clear. 3E Atlas was unlike anything humanity had ever encountered. Its behavior defied explanation, its composition was unlike any known natural object, and its presence raised questions that challenged our understanding of the universe. The silence from Western observatories was no longer just a matter of protocol or coordination. It was a reflection of the fear and uncertainty that gripped the scientific community. For the first time in history, humanity was confronted with the possibility that we were not alone in the universe, and that the others might be far more advanced than we could ever imagine. The final piece of the puzzle came from an unexpected source. On November 23, 2028, a group of amateur astronomers in Japan captured a series of images that would change everything. Using a network of small but highly sensitive telescopes, they had been tracking 3IE Atlas for weeks, documenting its every movement. During one of their observations, they witnessed something extraordinary. 3E Atlas appeared to split into two distinct objects, each moving in opposite directions before merging back into a single body. Observation. The Japanese amateur astronomers captured clear images of 3IE Atlas splitting into two separate objects and then merging back together. The event lasted approximately 17 minutes and was recorded in high-resolution detail. Interpretation. The splitting and merging of 3IE Atlas suggested that it was not a single solid object, but rather a collection of smaller components that could operate independently. This behavior was unlike anything seen in natural comets or asteroids and strongly implied an artificial origin. Speculation. If 3IE Atlas was composed of multiple components, it could explain its ability to evade detection and alter its behavior during the blackout hour. Perhaps each component was programmed to perform specific tasks, such as gathering data or avoiding observation. This raised the possibility that 3IE Atlas was not just a probe or vessel, but a swarm of smaller devices working in unison. The implications of this discovery were staggering. If 3IE Atlas was indeed a swarm of devices, it meant that humanity was not dealing with a single object, but a network of advanced technologies. The question of who, or what, was controlling these devices loomed larger than ever. Were they remnants of an ancient civilization drifting through space for eons? Or were they the product of an extraterrestrial intelligence sent to observe and study our world? The silence from the West finally broke on December 1, 2028, when NASA issued a press release acknowledging the unusual behavior of 3IE Atlas. While the statement stopped short of calling it an artificial object, it conceded that the available data did not align with known cometary activity. The agency promised further investigation and called for international cooperation in studying the object. However, the damage was already done. The world knew that something was out there, something that defied explanation and challenged our understanding of the universe. In the months that followed, 3EE Atlas became a symbol of humanity's curiosity and fear. It was a reminder that the universe was vast and full of mysteries, and that our place in it was small and uncertain. For some, it was a source of wonder, a glimpse into the unknown that inspired dreams of discovery. For others, it was a harbinger of the unknown, a reminder that we were not alone, and that the others might be far more advanced than we could ever imagine. But for everyone, it was a turning point, a moment when the world looked up at the sky and saw something it had never seen before. And in that moment, everything changed. Part 11. The System. China's discovery didn't create fear, it confirmed it. It confirmed that the object we welcomed as an innocent interstellar visitor was behaving like something aware of when it was being watched, something that responded to solar energy, not with melting, but with precision. Something that structured its tail, reshaped its coma, and adjusted its brightness like a mechanism running through a set of instructions written somewhere far beyond our sun. The data was undeniable. 3IE Atlas was not just a celestial wanderer, but a piece of technology, alien in origin and purpose. Its movements were too deliberate, too calculated to be the result of natural forces alone. The object's trajectory had been analyzed by supercomputers running trillions of simulations, each one refining the odds that this was not a random occurrence. The numbers were stark. The probability of 3IE Atlas behaving as it did due to chance was less than 1 in a billion. The fear was never that 3E Atlas would crash into Earth. The fear was that it was not passive, not random, not simply drifting, that it was doing something and waiting for the right moment to do it. And when that moment arrived, the international scientific community was blind except for one nation. China's early detection systems, a network of over 4,000 optical and radio telescopes scattered across the country, had been monitoring the object for months. Their observations, coupled with advanced AI algorithms, had detected subtle patterns in the object's behavior that other nations had missed. These patterns suggested a level of intentionality that defied explanation. The algorithms, trained on decades of astronomical data, flagged anomalies in 3IE Atlas's movements that were so precise they resembled the work of an intelligence. The Chinese government, always cautious, had kept their findings classified. But as the evidence grew, so did the urgency to act. On October 12, 2035, a secret meeting was convened in Beijing, attended by the country's top astrophysicists, military strategists, and government officials. The room was dimly lit, the air thick with tension. On the screens, simulations of 3IE Atlas flickered, showing its trajectory, its structural changes, and its projected path. The scientists explained that the object was not just responding to solar energy, but harnessing it, redirecting it in ways that seemed to defy the laws of physics as we understood them. The simulations showed 3IE Atlas absorbing solar radiation at rates that exceeded any known material's capabilities, suggesting it was built from something far beyond human engineering. Observation: 3E Atlas had altered its course 5 times in the past 3 months, each time aligning itself with a specific celestial body, first Jupiter, then Mars, and finally Earth. The alignments were not random. They corresponded to moments when those planets were in direct opposition to the Sun. Speculation: this suggested that the object was using the gravitational pull of these planets to adjust its trajectory, a maneuver that required an understanding of celestial mechanics far beyond anything humans had achieved. Interpretation: if 3IE Atlas was indeed an alien artifact, it was not just a probe, but a vessel capable of navigating the cosmos with a level of precision that bordered on the miraculous. The object's ability to leverage gravitational forces in such a way implied it was designed by a civilization that had mastered physics on a scale we could barely comprehend. The fear was palpable. If 3IE Atlas was not passive, then what was its purpose? Was it a scout sent to observe and report back to its creators? Or was it something more sinister, a weapon or a tool designed to manipulate the very fabric of our solar system? The room fell silent as the simulations played out, showing potential scenarios. In one, the object entered Earth's orbit, deploying smaller probes that descended to the surface, each one capable of mapping the planet's geology, atmosphere, and biosphere in minutes. In another, it positioned itself between Earth and the Sun, blocking out sunlight and plunging the planet into perpetual darkness, triggering global cooling and ecological collapse. Each scenario was a nightmare, a vision of a future where humanity was no longer the dominant force in the universe. Scientists estimated that if 3IE Atlas were to block even 10% of solar radiation, global temperatures would drop by an average of 5 degrees Celsius within a year, devastating agriculture and ecosystems. The Chinese government's response was swift and decisive. Within days, a classified directive was issued, authorizing the development of a new generation of space-based defenses. Satellites equipped with advanced sensors and weapons were launched into orbit, their mission to monitor 3IE Atlas and, if necessary, intercept it. The international community was kept in the dark, unaware of the true nature of the threat. But as the days turned into weeks and the weeks into months, the fear grew. 3I Atlas continued to move, its trajectory unpredictable, its purpose unknown, and the system, the global network of telescopes, satellites, and scientists, stood ready, watching, waiting for the moment when the object would reveal its true intentions. The system was a marvel of human achievement, a network of over 100,000 individual instruments working in concert, sharing data across borders and languages, a testament to our collective hunger for knowledge and survival. The system was not just a collection of hardware and software. It was a living, breathing entity, a testament to humanity's ingenuity and resilience. It stretched across continents, from the frozen tundra of Antarctica, where the South Pole telescope scanned the skies in temperatures as low as 80 degrees Celsius, to the deserts of Chile, where the Atacama Large Millimeter Array, ALMA, peered into the cosmos from one of the driest places on Earth. From the mountains of Hawaii, where the Mauna Kea observatories sat at an altitude of over 13,000 feet, to the plains of Australia, where the Square Kilometre Array, SKA, spread across thousands of square kilometers, humanity's eyes were everywhere. And now it had found something that challenged our understanding of the universe, something that forced us to confront our own insignificance in the grand scheme of things. The fear was real, but so was the hope. Hope that 3IE Atlas was not a threat, but an opportunity, a chance to make contact with another civilization, to learn from them, to grow. Hope that the system, the global network of scientists and engineers, could rise to the challenge, could unlock the secrets of the object and use them to push the boundaries of human knowledge. And so, the world watched and waited, the system humming with anticipation, ready to face whatever came next. The future was uncertain, but one thing was clear: humanity would not go down without a fight. In laboratories across the globe, researchers worked tirelessly, decoding the signals 3IE Atlas emitted, trying to understand its language, its purpose, its intentions. They knew that the stakes were higher than ever before. The discovery of 3IE Atlas was not just a scientific breakthrough, it was a turning point in human history, a moment when we were forced to look beyond our own planet and consider our place in the cosmos. Part 12. The Missing Chapter. China's measurements stitched the missing hours into a continuous timeline. 16 observatories across China, working in unison, recorded every fluctuation, every inexplicable spike in data. The result is a timeline so precise it feels almost alive, a seamless curve that stretches across the blackout period like a bridge over an abyss. And that seamless curve is the most unsettling part, because when you look at it, the behavior isn't chaotic. It's coherent, purposeful, like a trajectory correction, like an activation sequence, like a response. Every pattern the West missed, China captured. Every doubt the West tried to dismiss, China confirmed. Every fear scientists whispered privately has now become the center of the conversation. The Beijing Aerospace Command Center, a sprawling facility nestled in the heart of China's capital, became the nerve center for this unprecedented operation. Over 300 scientists and engineers worked around the clock, poring over terabytes of data, cross-referencing signals from ground-based telescopes, satellites, and even classified military surveillance systems. The scope of the operation was staggering. Thousands of hours of footage, millions of data points, and countless simulations were analyzed in real time. What they saw defied conventional explanation. The object, 3IE Atlas, didn't behave like a piece of space debris or a malfunctioning satellite. It behaved like something deliberate, something that seemed to adapt to observation, as if aware of the scrutiny it was under. The facility itself became a microcosm of the larger mystery unfolding above. In the dimly lit control rooms, dozens of screens flickered with real-time data streams, while teams of specialists huddled over workstations, their faces illuminated by the glow of complex algorithms and satellite feeds. The air was thick with tension and the hum of quiet whispers, as if the very atmosphere had become charged with the weight of discovery. At one point, a senior researcher recalled, the object's trajectory shifted abruptly, defying the laws of orbital mechanics. It was like watching a ghost move through walls, he said. It shouldn't have been possible, but there it was, right in front of us. If 3IE Atlas behaves differently depending on who is watching, then what exactly is watching us back? That's what this comes down to. Not aliens, not fantasy, not Hollywood, but something far simpler and far more frightening. We are studying an object that does not behave like an object. It behaves like a system, one that has no obligation to reveal itself to us. One that used the blackout window to show a different face, a different structure, a different truth. Observation. The object's behavior during the blackout was marked by sudden changes in velocity, temperature, and electromagnetic output. At one point, its surface temperature spiked to over 3,000 degrees Celsius, far exceeding the thermal capacity of any known material. Yet, moments later, it returned to normal, as if nothing had happened. These fluctuations were not random. They followed a repeating pattern, almost like a code. One sequence in particular caught the attention of the Chinese team, a series of electromagnetic pulses that appeared to form a mathematical progression. When analyzed, the sequence seemed to align with the Fibonacci series, a pattern found throughout nature and often associated with growth and structure. The Chinese team noticed something else. The object seemed to respond to their attempts to study it. When they focused high-resolution imaging on its surface, it would blur, as if actively resisting observation. When they switched to lower-resolution scans, the surface details sharpened, revealing intricate structures that resembled circuitry. It was as if the object was choosing what to reveal and what to conceal. On one occasion, a team using infrared imaging captured a fleeting glimpse of what appeared to be a lattice-like structure beneath the surface, glowing with an internal energy source. The structure seemed to pulse, almost as if it were breathing, before disappearing again. Interpretation. This behavior suggests a level of adaptability that goes beyond the capabilities of any human-made technology. Some researchers have speculated that the object could be a form of advanced AI, capable of learning and adjusting its behavior in real time. Others have proposed even more radical theories, suggesting it could be a manifestation of something entirely new, a system that operates on principles we don't yet understand. One hypothesis put forth by a small but vocal group of scientists is that 3IE Atlas could be a form of quantum intelligence, a system that exists in multiple states simultaneously and interacts with its environment in ways that defy classical physics. The implications of this are staggering. If the object is indeed a system, then it raises the question of intent. Is it here to observe us, to learn from us, or to intervene in some way? And if it is capable of adapting to our attempts to study it, what else might it be capable of? The Chinese data doesn't provide answers, but it does force us to confront the possibility that we are not the only intelligence in the universe, or even on this planet. The idea that 3IE Atlas could be a form of non-human intelligence, whether artificial or otherwise, challenges our understanding of what intelligence itself means. If it is capable of learning, adapting, and even communicating, then it demands a reevaluation of our place in the cosmos. Speculation. Some have drawn parallels between 3IE Atlas and historical accounts of unexplained phenomena. The Tunguska event of 1908, for example, remains one of the most mysterious incidents in modern history. An object believed to be a meteor exploded over Siberia with the force of 185 Hiroshima bombs, flattening over 80 million trees, yet no impact crater was ever found, and the object itself was never recovered. Could 3IE Atlas be a similar phenomenon, one that defies our current understanding of physics and engineering? Or is it something else entirely, a system that has been observing us for centuries, waiting for the right moment to reveal itself? The Chinese government has been cautious about releasing the full extent of their findings. While they have shared some data with international partners, much of it remains classified. Sources within the Chinese scientific community have hinted at even more startling discoveries, including evidence that the object may have been in orbit for far longer than previously thought. If true, this would mean that 3IE Atlas has been observing us for decades, if not centuries, watching, learning, and waiting. Some researchers have even suggested that the object's behavior during the blackout was not its first interaction with humanity. Ancient texts, myths, and folklore from around the world contain stories of strange objects in the sky, often described as falling stars or heavenly messengers. Could these stories be echoes of past encounters with 3IE Atlas or similar systems? The final piece of the puzzle is the most unsettling. The Chinese data suggests that the object's behavior during the blackout was not an isolated event. It was part of a larger pattern, one that stretches back in time and across the globe. If this is true, then 3IE Atlas is not just a single object. It is a piece of a much larger system, one that has been quietly shaping our world from the shadows. And if that system is now revealing itself, it begs the question, why now? What has changed to make it step out of the shadows and into the light? Is it a response to our technological advancements, our growing presence in space, or something else entirely? The answers, if there are any, remain hidden in the data, waiting to be deciphered like a message from another world. Part 13. The Divided Sky. Humanity is divided not by interpretation, but by information. One nation holds the missing chapter, and the universe is not waiting for the others to catch up. As 3E Atlas continues its silent path through the solar system, drifting at speeds exceeding 100,000 miles per hour, accelerating in ways that defy our current understanding of propulsion, and reshaping itself under the relentless light of our sun, we are left with a truth that can no longer be ignored. We didn't just detect an interstellar object, we detected an interstellar intent. The object, now designated 3IE Atlas, was first observed in 2017, hurtling through our solar system with a trajectory that suggested it originated far beyond the boundaries of our own star system. Its appearance was unprecedented, an elongated cigar-shaped object tumbling end over end, unlike any asteroid or comet ever recorded. Its surface, a dull reddish hue, bore no signs of the cometary outgassing that typically accompanies interstellar visitors. Instead, it moved with a purpose that seemed almost deliberate, as if guided by an unseen hand. The data poured in from observatories around the world. Hawaii's Pan-STARRS telescope, the European Southern Observatory's Very Large Telescope in Chile, and even NASA's Hubble Space Telescope. Each observation added layers of complexity to the mystery. 3IE Atlas was not simply an inert piece of rock or ice. It exhibited behavior that suggested it was something more. Its trajectory, for instance, was not purely gravitational. Subtle course corrections, detected through meticulous analysis of its motion, hinted at the presence of an internal mechanism, a propulsion system far beyond anything humanity has yet achieved. The implications were staggering. If 3IE Atlas was indeed an artificial object, it meant that humanity was not alone in the universe. More than that, it meant that another civilization, perhaps millions or billions of years ahead of us in technological development, had sent a probe to our solar system. The question of intent loomed large. Was it a scout sent to gather data on our star system? Was it a messenger carrying information meant for us to decipher? Or was it something more ominous, a harbinger of an encounter we were not yet prepared to face? The international community was split. Some nations, eager to claim leadership in the emerging field of interstellar diplomacy, rushed to analyze the data and propose theories. Others, more cautious, called for restraint and further observation. But one nation stood apart. With access to classified information and advanced technology, it had uncovered something the rest of the world had not, a missing chapter in the story of 3E Atlas. This missing chapter, it was rumored, contained evidence of deliberate communication. Signals intercepted from the object, encoded in patterns that defied easy decryption, suggested a level of sophistication far beyond anything humanity had encountered. These signals, if confirmed, would prove that 3IE Atlas was not just an object of curiosity, but a deliberate attempt at contact. The universe, it seemed, was not just paying attention. It was reaching out. The consequences of this revelation were immediate and far-reaching. Diplomatic tensions rose as nations accused each other of withholding information. Scientific collaborations fractured under the weight of secrecy and mistrust. The once unified global effort to understand 3IE Atlas devolved into a race for dominance, with each nation scrambling to be the first to unravel the object's secrets. Meanwhile, 3IE Atlas continued its journey unperturbed by the chaos it had sparked. Its trajectory took it past the orbit of Jupiter, where it underwent another subtle course correction. This time, the change was more pronounced, as if the object was deliberately adjusting its path to avoid a collision with one of Jupiter's moons. The maneuver was recorded by telescopes around the world, and the data was irrefutable. 3IE Atlas was not merely drifting, it was navigating. The realization sent shockwaves through the scientific community. If 3IE Atlas was capable of such precise navigation, it meant that its creators had mastered technologies far beyond our own. It meant that somewhere in the vast expanse of the cosmos, a civilization existed that could traverse the stars with ease. The implications for humanity were profound. Our understanding of the universe, of our place in it, and of the possibilities that lay before us were forever altered. But the story of 3IE Atlas did not end there. As it continued its journey, it began to emit a new signal, a pulse of energy that seemed to be directed not at Earth, but at the stars beyond. This signal, far more complex than the first, contained patterns that defied easy interpretation. Some speculated that it was a message intended for another civilization far beyond our own solar system. Others suggested it was a beacon, a call for help, or a summons to a rendezvous point in deep space. Whatever the truth, one fact remained clear. The universe was not silent. It was speaking, and it was up to humanity to listen. The divided sky above us was no longer a barrier, but a challenge, a call to unity, to cooperation, and to the pursuit of knowledge that transcended borders and ideologies. The story of 3IE Atlas was far from over, but its message was already clear. We are not alone, and the universe is waiting. Observation. The behavior of 3IE Atlas, from its trajectory adjustments to its emitted signals, suggests a level of technological sophistication far beyond human capability. The object's ability to navigate and communicate indicates intent, though the nature of that intent remains unclear. Interpretation. The division within the international community over 3IE Atlas highlights the inherent challenges of global cooperation in the face of unprecedented discoveries. The withholding of information by one nation has exacerbated tensions and undermined trust, yet it has also accelerated the pace of scientific inquiry and technological development. Speculation. If 3IE Atlas is indeed an artificial object sent by an advanced civilization, its purpose could range from exploration to communication or even intervention. Its signals, if decoded, could provide humanity with insights into the nature of the universe, the existence of other intelligent life forms, and the future of our own civilization. The possibility of further contact, whether direct or indirect, raises profound questions about our readiness to engage with the cosmos on equal terms. Part 14. The final question. If this story left you questioning what really entered our solar system, don't look away now. The next data drop could change everything we think we know. In 2017, Oumuamua, the first observed interstellar object, sped through our solar system at 196,000 miles per hour, defying easy classification. Its elongated shape, unlike any asteroid or comet we've seen before, sparked global curiosity and debate. Was it a natural phenomenon or something more extraordinary? Then in 2019, Borisov arrived, a comet from another star system, trailing a tail of gas and dust, a cosmic traveler bearing witness to the vast, unexplored territories beyond our own. These two visitors, Oumuamua and Borisov, were just the beginning. Astronomers now estimate that interstellar objects pass through our solar system at a rate of at least one per year, though most go undetected due to their small size and the limitations of our technology. The question remains, are we witnessing the first interstellar systems humanity has ever seen in motion? Or is this something far more profound, a glimpse into a universe that not only watches, but responds? The Veracity. Rubin Observatory, set to begin operations in 2024, will revolutionize our ability to detect these interstellar visitors. With its 8.4-meter telescope and 3.2 gigapixel camera, it will scan the entire visible sky every 3 nights, generating over 20 terabytes of data daily. This unprecedented capacity will allow us to observe not just the movement of stars and galaxies, but the subtle traces of objects passing through our solar system. Some scientists speculate that these interstellar visitors could be remnants of distant planetary systems, ejected during violent collisions or gravitational disruptions. Others suggest they might be the building blocks of new worlds, drifting through the cosmos until captured by the gravity of another star. But what if these objects are not just inert debris, but something more intentional? In 2018, researchers at the Harvard-Smithsonian Center for Astrophysics proposed that Oumuamua's unusual acceleration, which could not be explained by gravity alone, might be the result of solar radiation pressure acting on a thin artificial sail. While this hypothesis remains highly controversial, it raises the tantalizing possibility that some interstellar objects could be technological in origin. If even one such object were discovered, it would redefine our understanding of the universe and our place within it. The search for extraterrestrial intelligence, SETI, has long been focused on detecting radio signals or laser pulses from distant civilizations. But what if the evidence we seek is not a message in the night sky, but a physical artifact drifting through our solar system? The silence of the cosmos has spoken. In 1977, the Voyager 1 spacecraft was launched, carrying with it the Golden Record, a collection of sounds, images, and music from Earth, intended as a message to any extraterrestrial civilization that might encounter it. Today, Voyager 1 is over 15 billion miles from Earth, hurtling through interstellar space. It is a testament to humanity's curiosity and our desire to connect with the unknown. And now, it's our turn to listen. As we refine our instruments and expand our search, We stand on the cusp of a new era of discovery. The universe is vast, and its mysteries are many. But with each interstellar visitor, with each new observation, we inch closer to understanding our place in the cosmic tapestry. Whether these objects are natural or artificial, they remind us that we are not alone in our journey through the stars. The universe is alive with motion, with stories untold, and with questions that beckon us to look deeper, to listen closer, and to wonder.